Have you ever wondered what the fastest things in the universe are? Today we're exploring cosmic speedsters, from elusive neutrinos, fast pulsars, to enigmatic black holes and quasars. We'll cover particle accelerators, supernovae shockwaves, the cosmic microwave background radiation and waves. These are intriguing remnants and phenomena of our universe, each moving at considerable, mind-boggling speeds. The journey promises to be exhilarating as we delve into the mysteries surrounding these speedy cosmic entities. Are you ready to delve into the fascinating world of speed in the cosmos? Let's start our countdown. At number 10, we have cosmic microwave background radiation. This is not your typical form of radiation. It's the afterglow of the Big Bang, the universe's most cataclysmic event. Just imagine, an echo of the Big Bang, still reverberating almost 14 billion years later. This radiation permeates the entire universe, filling it with a faint, almost imperceptible hum. Its discovery in the mid-20th century was nothing short of groundbreaking, offering the first tangible evidence that our universe had a beginning. But what about its speed? Well, it's nothing short of breathtaking. The cosmic microwave background radiation moves at nearly the speed of light, around 299,792 kilometers per second in a vacuum. That's like circling the Earth more than 7 times in a single second. Remarkable, isn't it? Moving at nearly the speed of light, it's a remnant from the dawn of the universe. Supernovae shockwaves take our number 9 spot. Now let's delve into the fascinating world of supernovae. These are massive stars that end their lives in a spectacular explosion, releasing an enormous amount of energy into the universe. But what's truly amazing is the shockwave that follows. As the star explodes, it creates an outer layer of gas that expands outward. This gas layer is then pushed by the supernova's energy, creating a shockwave. Now, this isn't just any ordinary shockwave. It's a cosmic juggernaut, a tidal wave of energy that can ripple across entire galaxies. The speed at which these shockwaves travel is truly staggering. Imagine this. If a car could maintain the speed of a supernova shockwave, it could travel from the Earth to the Moon in just about 5 seconds. Now that's fast. These shockwaves are not just fast, they also play a crucial role in the universe. They spread heavy elements forged in the heart of the dying star across space, seeding future generations of stars and planets. These shockwaves rocket through space at mind-boggling speeds. Our number 8 spot goes to particle accelerators. Now, these are not cosmic phenomena. Rather, they are marvels of human engineering. Particle accelerators are sophisticated machines that use electromagnetic fields to propel charged particles to incredibly high speeds, often very close to the speed of light. Think of it as a racetrack, but for subatomic particles like protons. These particles are sped up and whizzed around the track, gaining more and more speed until they're zipping along at velocities that dwarf even the fastest car on the planet. It's an awe-inspiring feat considering that these are some of the tiniest things known to us, yet they become some of the fastest thanks to our technological prowess. Remember, the speed of light is the ultimate speed limit in the universe, and our clever particle accelerators are able to push these particles to the brink of this limit. In our labs, we can create some of the fastest things in the universe. Quasars take the number 7 spot. You see, quasars, short for quasi-stellar radio sources, are the ultra-bright, energetic heart of distant galaxies. They're not just bright, they're exceedingly bright, outshining their host galaxies and virtually everything else in the universe. So, what's behind this incredible luminosity? It's all due to the supermassive black holes at their centers. As matter spirals into these black holes, it forms an accretion disk and heats up to incredibly high temperatures. This process releases a tremendous amount of energy, causing quasars to glow brilliantly. But it's not just about brightness. Quasars are also all about speed. The energy they emit jets out into space at speeds close to that of light. That's right. These distant celestial powerhouses release jets of energy that race through the universe nearly as fast as light itself. These celestial bodies are truly a spectacle of speed. At number 6, we have galaxy clusters. These gargantuan gatherings of galaxies are not stationary, as you might imagine. Instead, they're whizzing through the cosmos at jaw-dropping speeds. Galaxy clusters are essentially groups of galaxies, bound together by the irresistible pull of gravity. The gravitational forces between galaxies are so strong that they can propel these clusters to speeds of thousands of kilometers per second. What's more, these clusters aren't just moving in any old direction, no. They're usually heading toward areas of the universe where the gravitational pull is even stronger. This phenomenon, known as peculiar velocity, adds another layer of complexity to the already mind-boggling speed of galaxy clusters. So next time you gaze up at the night sky, remember this. Those tiny specks of light are part of massive galaxy clusters, and they're hurtling through the universe faster than you can possibly imagine. These giant structures are on the move at incredible speeds. Black holes take the number 5 spot. These fascinating and mysterious wonders of the cosmos are regions of space-time where gravity is so strong that nothing, absolutely nothing, can escape its clutches. Not even the fastest entity in the universe, light, can outrun a black hole's gravitational pull, hence their name. Black holes are formed from the remnants of massive stars. When such a star has exhausted the nuclear fuel, it collapses under its own gravitational force and forms a black hole. As a result, this causes a singularity in the fabric of space-time, which we know as the event horizon, the point of no return. The speed at which black holes pull things in is so immense that it warps time itself. This is due to their incredibly high escape velocities, the speed needed to escape their gravitational pull. This velocity is so high it exceeds the speed of light, making black holes incredibly fast in terms of gravitational forces. Nothing escapes a black hole, not even light. Our number 4 spot goes to pulsars. These fascinating objects are neutron stars, the collapsed cores of massive stars that have exploded in supernovae. They are incredibly dense, with a teaspoon of their matter weighing as much as a mountain on Earth. But what makes pulsars truly remarkable is their rapid rotation. Some of these celestial dynamos can rotate hundreds of times per second. This rotation creates a lighthouse-like beam of electromagnetic radiation that we can detect here on Earth. This radiation sweeps across the universe at the speed of light, creating a pulsing effect that gives pulsars their name. The fastest known pulsar, PSR J1748-2446 AE, rotates a mind-boggling 716 times a second. That's faster than a kitchen blender. With each rotation, the pulsar emits a burst of radiation, flinging it across the cosmos at the ultimate cosmic speed limit, the speed of light. These celestial lighthouses are spinning at unimaginable speeds. Neutrinos take the number 3 spot. Now, neutrinos are not your everyday particles. These tiny subatomic entities are known for their incredible speed, zipping through the universe nearly as swiftly as light itself. What makes them truly fascinating is their minuscule mass. You see, unlike many of their more hefty counterparts, neutrinos are extraordinarily light. This allows them to move at such breathtaking speeds, but that's not all. Neutrinos have another ace up their sleeve. They possess the uncanny ability to pass through matter with minimal interaction. Imagine a ghost, if you will, phasing through walls unimpeded. That's essentially what neutrinos do, but on a cosmic scale. From stars to planets, nothing stands in their way. They simply keep on going, traveling close to the speed of light. So let's give a big round of applause for neutrinos. These tiny particles, with their near-light speed and ghost-like ability to pass through matter, truly deserve their place on our list. These tiny particles are almost as fast as light itself. Our number 2 spot goes to gravity waves. These fascinating phenomena were predicted by none other than Albert Einstein himself in his theory of general relativity. Gravity waves are essentially ripples in the fabric of space-time caused by massive objects accelerating or decelerating. Imagine a ship sailing across the ocean, causing waves to ripple out from it. In a similar way, when a massive object like a black hole or neutron star accelerates, it causes these gravity waves to ripple across the universe. Now here's the truly mind-bending part. These gravity waves, these ripples in space-time, they travel at the speed of light. Yes, you heard it right, the speed of light. That's nearly 300,000 kilometers per second. So when two massive objects like black holes collide, the ripples they create in spacetime move at this incredible speed. Riding the ripples of spacetime, gravity waves are as fast as it gets. And the fastest thing in the universe is light. When we think of speed, light is the unbeatable champion. It travels at an almost unfathomable speed of approximately 299,792 kilometers per second in a vacuum. That's equivalent to a whopping 186,282 miles per second. Imagine this: if you were to travel at the speed of light, you could go around the Earth about 7.5 times in just 1 second. Now that's fast. Light's speed is so impressive that it serves as a universal constant in the realm of physics, underpinning theories such as Einstein's theory of relativity. In fact, the speed of light is so critical to our understanding of the universe that much of modern physics would crumble without it. At an astounding 299,792 kilometers per second, nothing is faster than light. So there you have it, the top 10 fastest things in the universe. We started our journey with the cosmic microwave background radiation, the afterglow of the Big Bang itself. This permeates the universe, moving at speeds that almost match the velocity of light. Then, we witnessed the incredible force of supernova shockwaves, racing through space at mind-boggling speeds during a supernova explosion. We then dove into the realm of particle accelerators, man-made marvels that propel subatomic particles such as protons to almost light speed. From there, we ventured into the distant universe, where we found quasars, these extremely bright and energetic celestial bodies that emit energy at speeds close to that of light. Our journey took us to the vast expanses of galaxy clusters, moving at thousands of kilometers per second due to the gravitational forces between galaxies. Then, we encountered the enigmatic black holes, with escape velocities so high that nothing, not even light, can escape their gravitational pull. We then whirled with the pulsars, rapidly rotating neutron stars that can spin hundreds of times per second, emitting beams of electromagnetic radiation. We also delved into the world of neutrinos, these tiny subatomic particles that, despite their minuscule masses, can zip very close to the speed of light. We then rode the gravity waves, ripples in space-time predicted by Einstein's theory of general relativity. These waves, like light, travel at the maximum speed limit of the universe. And of course, we ended with light itself, the fastest known entity in the universe, racing through the vacuum of space at approximately 299,792 kilometers per second. So, it's quite clear that when it comes to the universe, speed is a fundamental characteristic, whether it's the speed of light, the spin of a pulsar, or the velocity of a galaxy cluster. It's all a part of the grand cosmic ballet that makes our universe so fascinating and so endlessly intriguing. From light to gravity waves, the universe is full of speed. Until next time, keep looking up and wondering about the cosmos.